Hello and welcome to this lesson on the Pythagorean Theorem. The learning target for this video is applying the Pythagorean Theorem. So here's what the Pythagorean Theorem is. It's very famous and it is used a lot throughout mathematics anytime or very frequently whenever there is a right triangle. And it is a squared plus b squared is equal to c squared. So what you really have to do is commit this to memory. A squared plus b squared equals c squared. Now, what this means, this all corresponds to right triangles. So again, it only works for right triangles, which means they have a 90-degree angle. And so you have to look for this. If it doesn't have a right angle, then this thing will not work. Now, A and B are the side lengths of the triangle, so A plus B. C is something we call the hypotenuse, and that is the longest side of a right triangle. And so that's what A, B, and C refer to. They're components of the triangle. So you'll take whatever the measure is of A, whether it be like 3, 10, 30, whatever it is, square it, and then you'll add it to whatever the measure of B is, squared, so you got to square that as well, and then that's going to equal C squared. Now, before we move any further, I want to go over a few terms, if you will, or some vocab that's going to be used. So the first one is a simple one, leg. And what that just means is either side of a triangle that is not the hypotenuse. All right, and then hypotenuse is probably a word you're looking at and you're like, whoa, what is that? So that's the second vocab word we'll talk about. Hypotenuse. Hypotenuse. That's how you spell it. All right, hypotenuse, that is the longest, oops, that's how you spell long though. The longest side of a right triangle. So taking a look at this, A and B, these are both, or all of these, are going to be considered legs. So let's draw lines over here. Those are all legs. Whereas part C, that is our hypotenuse. That is the long side. Now, before we get into actually crunching some numbers, some fine print and details that we need to keep in mind. The first thing is we have to watch out for order of operations. So order of operations. And something we're going to be dealing with a lot is squared. So a squared plus b squared. Well, keep in mind that a squared and b squared is the same thing as saying a times a plus b times b. Order of operations, you have to do your multiplication before you can do your addition. So be mindful of that. Second, we're going to be doing a lot of square rootings. And so square rooting undoes squaring. So for example, square root of a squared is equal to a. Or if we're dealing with some numbers, let's say x squared is equal to 4, you take the square root of both sides and x equals 2. So we're going to be seeing a lot of that. So just kind of keep in mind those principles right here. First of all, order of operations. Second of all, square rooting undoes squaring. And so now with that being said, let's take a look at some actual examples. So in these examples, we're going to find the missing side length, and it's just different variations of finding the missing side. The missing side. Now what I'm going to show you in the first two examples is finding the hypotenuse, the longest leg, and then after that I'm going to show you examples where you have to find one of the legs. So here it's again just all about using a squared plus b squared equals c squared. Anytime you see a right triangle and you need to find a side length, you have to pull out this formula. And then it's about plugging in the numbers. So what I'm going to do is put in 30 for A and 40 for B. 30 squared plus 40 squared is equal to C squared. Now, these numbers might seem daunting, 30 squared, but use your calculator. So 30 times 30 is 900, plus 40 times 40, 1600, is equal to C squared. Now, you notice what I did. I did order of operations. I took care of my exponents or multiplication first. Now I'm going to do my addition. So 1600 plus 900 is equal to 2500, and that's equal to C squared. Take the square root of both sides. Now, sometimes your answer might be the square root of 2500, but you never know what might happen with some of these numbers, so try it. And when we do that, C ends up equaling 50. And so that would be 50. Let's do another example. Let's scroll up a little more. Too far. There we go. All right, on this triangle, let's say we have 7 and 24. So same thing, you see a right triangle, you're trying to find a missing side length, you have to think a squared plus b squared equals c squared. So start plugging in some values, and so we'll get 7 squared plus 24 squared. And it doesn't matter what you use for a and b, because you're going to add them up. And so it could be 24 squared plus 7 squared, you'll get the same thing, is equal to c squared. And so 7 squared, that one's easy enough, 49. 24 squared is 576. And then we're going to add 49 to that eventually, because right there that's equal to c squared. And so when we add them up, we get 625 is equal to c squared. At this point, you take the square root of both sides, and c equals, take the square root of 25. There we go. So those are two examples of finding the hypotenuse. Now let's do two examples of finding a different side length where we know the hypotenuse. So actually this is example number 3. And so now we have 41 and 40, and then this one is unknown, and so we have to figure this out. So the difference, we're still dealing with right triangles. When we write a squared plus b squared equals c squared, is 41 has to go somewhere. So 40 and then whatever this one is could be either a or b, it doesn't matter. But 41 has to go into c squared. And then I'll just put 40 into a squared. And so I'll get 40 squared plus b squared is equal to 41 squared. Now again, you have to use order of operations. It might be really tempting to subtract 40 from both sides and then be like, hey, it's 1 squared and it's easy. No, you got to see it through all the way. So 40 squared is 1600 plus b squared is equal to 41 squared, which is 1681. Subtract 1600 from both sides. So here we have to do a little more solving to get b squared by itself. And so b squared now equals 81. Take the square root, and b has to equal 9. Okay, let's do another example so you get a good look at that. So our fourth and final example. In this one, keep it maybe a little easier. Go 15, 12, and unknown. So that's why I got that circled. Again, a squared plus b squared equals c squared. The only thing that really matters is that 15 goes into c squared. And here, just for fun, I'll put 12 into b squared, just to show you that it doesn't matter which way you do this. There we go, having some technical issues. All right, a squared plus 12 squared is equal to 15 squared. So a squared plus 144 equals 225. Subtract 144, subtract 144. So 225 minus 144 is, what a coinkadink, 81 again. Take the square root of both sides. A squared equals 9. Or sorry, a equals 9 because a squared equals 81. So there we go. That's how you do or how you use the Pythagorean theorem. It's all about just memorizing a squared plus b squared equals c squared. And now in this video, we're going to do things a little bit differently. I have some practice problems for you here. So what I want you to do is on your own, try it out. Find the missing side length. So here we'll call this guy 8, this one 15. Find out, and we'll just for fun call this x. And then in number 2, let's give you a hypotenuse, 26, the side length, and then we'll call this guy y. So on your own, use the Pythagorean theorem and try to solve these. And then this video, depending on when you're watching it, may be linked up to Edpuzzle, and you can answer the question in Edpuzzle to see whether or not you got it right. So good luck with your homework, and let me know if you have any questions.